Okay, when they talk about the one-to-one property of logarithms, that's where it says if the log of x equals the log of y, then x equals y. You just drop the logs off. Okay, now on this one, I actually have three separate terms. I'm going to highlight them for you. I have the natural log of an x squared minus 9. That's one term. Plus, come on, markers, work with me here. Natural log of 9 equals the natural log of 40. Those are three separate terms. You can only have one log on one side and one log on the other in order to use the one-to-one property. I got three separate logs. So two of those logs have to hook up somehow. Doesn't matter how you want to do it. Since these two are together on the same side and they're being added right here, you could use that log rule that says if you have the log of x plus the log of y, that'll equal the log of x times y. X times y. Whew. So I'm still going to have the natural log of 40 on the right side, and then on the left side I'll have the natural log of, I'm going to take the 9 multiply the 9 times the x squared minus 9. You're going to have 9 times the x squared minus 9. And if I distribute that, that will be a 9x squared minus 81. And that equals the natural log of 40. And now I have the log of this equals the log of that. So my this equals my that. And now solve for x. I know there's an x squared which makes it quadratic, but 81, the minus 81 and the 40 are like terms, so I am going to add 81 to both sides, which will give me, that cancels out, so I get 9x squared is equal to 121. And if you divide both sides by 9, the 9's cancel, so you get, follow me over here, I'm running out of room, so you get x squared equals 121 over 9, and then I will have to square root both sides, but remember you're supposed to have both a positive and a negative of whatever the square root of 121 over 9 is. Now what you're going to do is you're going to take the square root of both the numerator and the denominator separately. So these are going to equal a positive or a negative. The square root of 121 is 11 and the square root of 9 is 3. So, and both of those should work because if you were to plug them into where x is, the first thing you would do is square them. And it, well, if you square a, didn't mean to do that. If you square a positive or square a negative, it ends up being a positive. And 121 over 9 minus 9, that'd be 81. Yep, that'll be positive. They should both check. There shouldn't be an extraneous root. So let me go back here and separate your answers by semicolons. So negative 11 thirds, semicolon, 11 thirds. Booyah! Got him right.